Hello and welcome to Fullerton College's Print 101, Introduction to Printing. This particular lecture is going to cover two chapters which actually dovetail quite nicely. This is about lithography and offset lithography, as well as press systems and how they work. Chapters 14 and 15 from our textbook. Let's get started without further ado. How to publish a play. Wait, what? Playwriting? I thought we were talking about printing. Well, yes, we are. You see, plays are printed manuscripts. And in order to get one produced and made, you had to not just write a play and convince actors to star in it, you had to write a play and convince a publishing house to print and distribute the copies of your play to the different theaters around the area or around the world, around the area you want your play to be shown in. During the Age of Reason, there was a playwright named Alois Senefelder out of Germany. I forget which part of Germany. I'm sorry. I can look it up. It's online. Feel free to Wikipedia him. He's an interesting fellow. Apparently, he started as an actor. Then he decided what he really wanted to do was direct and write, so he wrote his own play. He made one called Connoisseur of Girls. I'm sure it was a wholesome story. And that was a pretty good success, so he decided he was a playwright. However, not long after, he wrote flops. And it didn't take long before he lost his backers and before the publishing houses were no longer willing to take risks on his plays. And so he did what any stilted playwright would do when he's faced with a crisis of being able to fund and or get loans to publish a new play. If you can't do it, what do? Why, obviously, you invent a new way of printing and do it yourself, right? Well, that's what he did. He tried to figure out a way of creating a printing system at his own place so he didn't have to rely on publishers to get his plays made. So he figured out, using some kind of age-old science, that water and oil don't like each other. So he figured out a way of creating his letters and creating his words on a wetted stone, W-E-T, not W-H-E-T at this point. We're not talking about knife sharpening. So on a dampened, dampened's a better word, a dampened limestone, which holds liquid pretty well. Hold on, something is going on over here that I don't care to hear. There we go. Darn computer pop-ups. Gosh. Quick side note, my annoying joke, sorry, has to come up because it just happened to me right now while I'm recording. If any of you are Game of Thrones, or more importantly, Song of Ice and Fire fans, you might remember a phrase here that I will paraphrase for you now from the Swordmaster, Serial Pharrell, paraphrase to computing. On computers, there is only one God, the God of auto-update. And what do we say to auto-update? Not today. Anyways, back to the story of Alois Senefelder. So he figured out that he could write with greasy ink on top of limestones that could then get dampened, and then he could just smear ink on top, and the ink wouldn't stick to the wet stone and only to the parts that already had ink. That way he could produce his own copies and not rely on publishing houses who otherwise were required to get his stuff made. He still was not a very good playwright and still didn't really get a whole lot of things going on in his life for his plays. However, he did turn some heads with his printing technique. People still thought his plays were boring and not worth seeing, and nobody was going to fund those things. But hey, buddy, you just figured out a way to print something, and his method was a lot easier to print pictures with, not just text. Lead type, it's very difficult to create a printing block and very expensive and costly to create a piece of lead type for a picture. You have to have a custom carving for each picture. But in lithography, litho from the old word stone, graphics, so stone imaging, in using lithography, you're able to actually hand draw on a stone. So suddenly you're able to reproduce artwork and reproduce it well, and in finer detail and in greater quantity than ever before for less money. So he turned a bunch of heads, and he and a composer of the same period, Franz Gleisner, which was the semi-related music video I gave you in this week's chapter on our Canvas shell as well here. If you're watching this and you're not in my class, go look up Franz Gleisner, G-L-E-I-S-S, or tall double S if you're actually typing on a German keyboard, N-E-R. He's a pretty decent, okay composer from the 1770s and 80s, but sorry, 80s and 90s. But he is of the older school of composition, and you know, I'm not here to judge, but you know, you don't know about him because he was around the same time as this other little child who toyed around on the piano and was named Mozart. Anyways, so Gleisner and Sennefelder worked together to create a printing company instead and to start using their new techniques to print. Again, lithography, in this case, it's not offset yet, it's just lithography. Lithography uses the age-old kindergarten experiment of oil and water not wanting to mix, at least not easily. Ink was oily. The earliest printing inks and even a lot of writing inks were some sort of soot, or they call it lamp black, but really it's soot from burnt candles and burnt oil lamps. And you mix that with linseed oil, which was the oil, at least not the eating oil, but the industrial oil of the pre-industrial revolution Europe. Linseed is the same thing you make linen out of. Since cotton wasn't big in Europe, it still isn't. It's linen is what grows there more easily. It all comes from flax, and you can eat flax, but linseed you don't really. Anyway, sorry. So linseed oil and lamp black makes the earliest printing inks. Oil and soot to make a black ink. The oil makes it sticky and stay to things. So it wasn't a huge leap to say, hey, ink is already oily. Water doesn't like oil. Why don't I use water to control this? And it worked really well. So here's an image transfer on a actual offset press. So here's an offset press. The older types of lithograph, the old lithographies, were done with a direct impression to the stone. The actual limestone used that was drawn on or etched on or printed on with the greasy ink to attract ink and dampen down to repel ink, that was like a printing plate, like the old lead type. You'd put the paper directly on it and press against it to transfer. Modern lithography is called offset lithography. The offset means that the plate does not touch the paper. The plate touches an intermediary called the blanket. This is one of the things that helps modern presses not get the paper quite as wet with all that water that's used to control the ink, because the water doesn't really transfer to the blanket. So nowadays you have the plate cylinder. The plate is no longer a piece of stone. Nowadays lithography is done on a chemically coated metal. Trust me, we'll get to that soon enough in this chapter. And the plate is wrapped around the plate cylinder. The plate cylinder presses against the blanket cylinder. The blanket cylinder is wrapped in something called a blanket, which is a rubber sleeve or a rubber, kind of like a rubber plate that's wrapped around it. So the rubber takes the ink from the plate and then presses that against the paper. The impression cylinder on the other side is what gives enough pressure against the blanket to force the ink to jump off the blanket and transfer itself onto the paper. Here's an offset press unit. Any offset press unit contains all the components necessary to print a single color of ink. It has a dampening system with water rollers and water. Now, water is water asterisk because a lot of times it's not pure water anymore. Now we use something called fountain solution, which is a slightly acidic mixture of water, acid, and gum arabic, which repels ink a little more accurately and is a little easier to control than strictly pure water, although the earlier ones used pure water. So we still call it a water system. So the water system and a series of water rollers will take water from the fountain pan, or whatever type of system you have built on your press. It changes from press to press, and adds that to the plate. After that, the ink rollers have done their job to take ink from the inkwell, spread it out, work it till it's tacky, and get it stuck to the plate as well. But you must dampen first. If you don't dampen the plate first, ink will stick to everything. So the water always contacts the plate before the ink, because once it's damp, then the ink won't stick. Because ink may not like water. Oil may not like water, but it's certainly fine with metal. Anyways, so the water, the ink rollers, the plate, the blanket cylinder, and the impression cylinder is all what's necessary to print one color of ink. If you want to print more than one color, you need more than one press unit. Smaller offset presses have a single unit, especially the old ones called duplicators, which aren't really used except for training these days, because there's this little company out of Palo Alto that kind of took over that market, and then everybody else took their idea, called Xerox. Anyways, Duplicators used to do what copiers do today, make cheap, quick, black and white copies, fast and dirty, and get them out there as quick as possible. Anyways, moving on. Developers. Haven't decided if I'm going to give you that video as well, but I might, from the now infamous Microsoft rally speech of developers. So developers are systems that help develop the plates. Modern offset litho plates are no longer imaged directly by grease pencils or people hand drawing on them. No. They are encoded in a light-sensitive emulsion. Now, the emulsion could either be ink-loving or water-loving. It could be one or the other. It's important to put the correct kind under your press, or you're going to be printing the opposite of what you think you're printing. But anyways, either one of those, part of it gets lased off or ablated or removed by the laser. It's actually, and depending on how you look at it, so other parts are hardened and kept, and then you wash off the debris of the stuff you don't want. It can be done manually. It can be done through machines that develop plates automatically or semi-automatically with very little or no input from humans necessary. Here's a little note, and my super awesome retro sci-fi picture here. The future. I often find it fun to go back and look at old art books and old, old science textbooks from the 40s, 50s, and 60s and earlier, and see what they thought the future was going to look like. Because, you know, haha, it's funny to see that they were wrong. Sometimes they were more correct than you think. Sometimes they weren't. Sometimes people were very prescient. Jules Verne figured out more or less how some modern submarines were going to work before the technology existed. That's pretty cool. But meanwhile, other people were very wrong about a lot of things. Our textbook goes into some detail about a printing technique that is not really the way things went. It's kind of the Betamax of printing. Anybody old enough to know what Betamax is, hopefully is chuckling softly to themselves. It's what VHS beat out to become videotape. Anyways, so there was this thing called waterless printing that they were coming up with, because if you haven't run an offset press yet, you don't yet know how annoying it is to maintain that water ink balance and all the extra materials and all the extra stuff you have to deal with and the chemicals you have to store. Why not find a way of making this work without the water? And they did. They found a way of making special plates that do not require a dampening solution and will repel the ink on their own just by being themselves. It's done through a silicone rubber layer instead of a water mixture. It's not the normal water type. However, they're finicky and they require climate control to work. If your humidity in the room or the temperature's off a little bit, then your press doesn't work. So they ended up being more hassle than they thought they were. And the real reason it didn't take off is, again, the same reason offset duplicators went away. Digital printing emerged. And digital printing doesn't need any water, and it's a lot easier, and it's more accurate, and it produces less waste. And why not just keep printing offset the way we've been printing it and just use laser plates? So waterless plates, they're the future that could have been. The future with robots and airships instead of airplanes, and everyone's traveling on Zeppelins places, and the whole world's covered in Art Deco architecture. And you know what? I kind of want to live in that world, just to be honest. So let's talk plates. I'll do my best check stand boy voice here. Paper or plastic? There we go. Paper or plastic, or metal. The three materials that plates are made out of are paper, plastic, and metal. The first two are just there kind of as jokes to the plastic bags and the paper bags, but still, you can have a plate made on plastic or the paper backing or with metal. Metal's most common because it's more durable and it lasts for longer print runs. I've used paper plates before. They're interesting. They're very much disposable. They're very much used for shorter runs. In fact, some paper plates are an interesting hybrid between digital printing and offset printing, where instead of being developed, some of them are hydrophilic, where they like water, and you print them through a digital press with its plasticized toner, and the ink / toner from the digital press acts as the oleophilic ink-loving areas. Anyways, I'm just about out of time. Well, let's finish this, actually. I'm getting ahead of myself by 20 seconds. There's grain added to the surface of these aluminum plates. It's mostly an aluminum or aluminum alloy. When you zoom in onto it a whole lot, you can see that it has a rough texture. That rough texture It's a very micro thing. You can barely feel it with your hands. It's a micro texture. That is what makes them water absorbent in some areas. And to make them not water absorbent, you remove parts of them. Or in some cases, the water absorbent areas are covered with a coating that gets removed. It depends on if you have a positive or negative acting plate. But we'll get back to that in another video or two.